Hello, everybody. Take your seats. We're going to get started here. And here we are, talking about the Ameritron AL1500 amplifier. I happen to have one of these. And what I'd like to talk to you about tonight is what I went through to get it refurbished and back on the air after about a 15-year period of time when it was sitting on the shelf. So first off, what is an AL1500? Okay. So the AL1500 amplifier. This is a full power 160 through 10 meter amplifier. It's been in production since about 1990. My particular one was built in 1998. I bought it used in 2001, used it for about 5 years, and then I put it on the shelf. And the reason it was on the shelf was when I moved, I didn't have a 240 volt line in the shack, so I didn't really use it. And I put the 240 volt line in a couple of years ago, and I thought, well, it's about time to get that amplifier going. When you've got something like this that's been sitting around for a few years, you don't just want to plug it in and see what happens. And the reasons are a little different than what you might consider, say, for a typical boat anchor radio. This is a very high power amplifier, a lot of energy in the power supply. And there's a few steps you want to go through to make sure everything is okay before you get it going. So by having this sitting around, I thought, there's a few goals I ought to have if I'm going to work on this. And one of those was I need to make sure the power supply is okay before I turn it on, kind of obviously. It's a high voltage device, very high voltage power supply. It's going to need some cleaning inside. The fan makes a lot of noise. So these big amplifiers are cooled by a blower, and it's noisy. It's not quite as loud as a vacuum cleaner, but it's pretty noisy. And there's a few other things that needed to be checked too. Ooh. So the first thing is cleaning, and cleaning is you take the cover off, and what you see inside is an accumulation of dust and dirt. Now this was stored with the cover on, and the cover's only got a very small area, about 4 by 6 inches, perforated metal for ventilation. But this is what filtered in over that time period. Now this was in my shack while I was remodeling the house. And it was also kind of doubling as my workshop, but even though I had some sheets laid over the radio equipment, a lot of dust got into things. You can see everything is pretty much covered. You definitely want to clean this out. And not because it looks bad, but this can cause some arcing in the high voltage supply. All this dust gets a little bit of moisture in it. It can become conductive, and you can have some problems. Okay. Fortunately, cleaning this kind of stuff is easy. This is just, dust. So you use whatever your favorite cleaning supplies are. I use some Windex and some swabs. And
did you use that on the mouse turds too?
No, this was not stored anywhere mice could get at.
What are those little black things in there?
Those are balls of dust. There's no. Fortunately, no mice got in. There was no mice in here. The amplifier was sealed up the whole time. Okay, so cleaning was easy. So the next step then is looking at the power supply, and the filter capacitors and the power supply are those blue things in the right-hand side. This is actually a pretty decent power supply in this amplifier. It's got a big Peter Dahl transformer inside. Peter Dahl's been in the business of power transformers for ham radio equipment for many years. I have a pretty good reputation for building reliable transformers. Power supply otherwise is pretty standard. It's a full wave rectified supply. One of the things that's kind of marginal in this design is the voltage rating on the filter capacitors. So this board has 8 filter capacitors, and they're 450 volts each, so that totals up to about 3,600 volts rated based on the ratings of the capacitors. The power supply itself runs right at that voltage. So this is what Ameritron has done for 30 years, and it works okay most of the time, I guess. And I never had any problems. And this whole thing is rated for continuous operation too. So continuous output at 1500 watts. So it's designed to be turned on and left on, I guess. So before getting to work on this, I had a few things I had to decide on. How far did I really want to get into this? What did I want to do? One of the things would be I could just replace the capacitors. But as you can see from the center picture there, they're kind of buried in there. So to actually get to replacing the capacitors, you have to disassemble the whole power supply. You have to pull it out. And I thought, well, if I'm going to go through all that trouble, maybe there's something else I need to do too. And if you've worked on old equipment, especially old transmitters, one of the things that's very common these days is somebody will have come up with an upgraded power supply board. And that turns out to be the case for this amplifier too. And so I found W9JI makes an Ameritron replacement board. It's a drop-in replacement. And one of the nice things about it, instead of those two boards, I don't know if that was clear in the previous one, the rectifiers are mounted on that little board up on top, which is then held up above the filter capacitor board by some standoffs. So you've got quite a contraption in there. This board has got everything on one. And it also has 10 capacitors instead of 8. So now you have a kind of a nominal capacitor voltage of 4,600 volts. So you got about 1,000 more volts built into your capacitors. And it's a drop-in replacement. So that's kind of nice. You don't have to really rebuild or redo anything. You get this board, you put the parts on it, and then it's pretty much good to go. Assembly was very simple. W9JI, the guy who designed the board, gives you a suggested parts list for parts for the capacitors and the resistors. So you go to Mauser, you put the parts list in, you buy them. It takes about an hour to put together, and it fits very nicely. And that's the board installed back in the amplifier. Pretty straightforward. The fan is loud. So how many of you guys have a linear amplifier? Does it have a loud fan? Yeah. Anybody with a quiet fan? Don has a quiet fan.
Yeah. Solid state.
Solid state. Okay.
And the other is fairly quiet.
Okay. And amplifiers vary. Some of these are real loud. Some of them are so loud. Some can be pretty quiet. This one, it's not as loud as a vacuum cleaner, but it was loud enough that when I would use it, I would put headphones on to be able to hear the radio. Okay. So I thought, is there something I can do to quiet this down? Yes, Tom.
I have one that uses 4,572s.
Okay.
It's a very old one, and it has like a whisper fan by the tubes. I used one of these computer fans from Stan and put that over on the power supply side to get rid of that heat. And it works on 12 volts.
Okay.
It's a pilot light source.
Okay. Yeah, this amplifier has got actually has a pressurized air delivery system that it's got a squirrel cage fan that pressurizes an area below the deck and forces air up through the cooling fins on the tube, and it's just noisy. So, a couple of things to do to try to make it less noisy. One is slow the fan. And Ameritron in the manual says that of all the fan speeds you can select for this, and there's 5 different speeds, any one of them will cool the tube just fine. But that if you're going to go for some continuous operation, like RTTY or something, that they recommend operating at a higher fan speed. There's also the opportunity to put some sound absorbing material or sound deadening material in here. And I found some that I thought would work pretty good. And I also tried isolating the fan from the chassis. So first with the fan speed, there's a transformer in there, and it's got some taps on it. And I put in a switch to select between two different taps on the transformer. Pretty straightforward. However, getting it in was not real straightforward because it didn't fit. And where I put the switch is, you can see the transformer. And to the left of the transformer, if you look real carefully, you might be able to see a little bit of the back panel in there. When the switch is installed, there's plenty of room between the transformer and the back panel, but there's no way to get it in without taking the transformer out. Not too bad of a job, but it had to come out. And so the picture on the left here shows you the space in the amplifier with the transformer removed. The switch is mounted on the back panel, and on the right-hand side, it's kind of hard to see down in the right-hand front. Those are the fan speed taps. So I figured out which taps I needed to select between, and now the switch is in place, and it switches between low speed and the medium high speed. Medium high was the original speed that it shipped. That took a little while to get that. And the switch now is out the back. There was actually an unused hole on the back of the amplifier. So it wasn't a big deal to mount that switch, just made the hole a little bit bigger, put the switch on.
That was a $100 factory option fan speed switch hole.
I don't think so. But and I bought it used anyways. Came like it came. So now it's got that in. So the other thing is to put some sound deadening material in there, sound absorbing material. And so what I tried was something called Hush Mat, which is an automotive product. It's used in cars to dampen vibration, and it's also used as a thermal barrier in cars. I had never used any of this stuff before. It's kind of interesting. You can see it's black, and it's like a sandwich of soft, kind of rubbery material with a layer of like very heavy aluminum foil and one side is adhesive. So it's very easy to work with. You just kind of cut it to the shape or size you want, peel off the paper on the back, stick it in place, and that's all there is to it. And so the idea here was just to really get into that fan cavity and cover all the surfaces. Anything I could reach, I covered with the Hush Mat. And that was pretty straightforward. One thing to keep in mind if you decide to do this to an amplifier is that the picture in the lower right is the case that's turned upside down on the table. That's the top cover. You want to make sure you don't put this material anywhere that's going to interfere with fitting when you put it back together. So you got to keep in mind where any of the internal baffles or parts are, and make sure you don't have this this material in the wrong spot.
Where'd you get the material?
Off of Amazon. Like everything else. Except for this. This came from Fleet Farm. So the last thing I tried was remounting the fan on a piece of gasket material. So this is just like a sheet of gasket material. I get it at Fleet Farm. I use it like on my farm equipment when I need to make replacement gaskets on some of my old stuff. You can see the fan on the left side of the picture. This is a squirrel cage fan. It sucks the air in on the side, blows it out the bottom. And I just made took a piece of the gasket material, cut it out to fit the mounting holes, and put a hole in the middle for the air to go through, and then bolted it back together. That was a little tricky because that fan compartment's kind of hard to get in there, and ended up having to turn the chassis up on the side, kind of hold the fan, and try to work the nuts and bolts by myself. But got it in there, and then put it all back together. Everything is all clean and shiny. No mouse turds. Everything is looking good. So now it's time to put some power on. The true test. So turn it on, and the first thing that happens is, fan starts up, and you're waiting now for the timeout timer to work. So, and the timeout is to give the tube filament time to heat up, and for the power supply capacitors to charge up slowly. And that takes about 2.5 minutes, and then it switches a relay, and of course, bang, something went wrong. Okay, yeah. What was it? After all this work, bang, that wasn't too good to hear. What happened? And that's that, that hush mat material I mentioned. That's like a sandwich of rubber with aluminum foil in the middle. Okay.
Arc.
It arced. And you can see it in the center there, the arc occurred here with an arrow pointing. That's where the high voltage lead goes through a partition wall inside the amplifier. I didn't leave enough clearance. I had about a 1/4 inch. I thought the insulation on the high voltage lead would be high voltage insulation. Well, it wasn't. It was just plain old hookup wire. So it's probably good for about 600 volts. Fuses worked. They protected everything. And the solution was just to make some more clearance around it. And for good measure, I put a piece of Teflon tubing over the wire, and it worked fine. And you can see where the arc occurred. So it was actually disheartening when it happened, but it was easy to fix. And it was something I should have realized it when I was working on it, that there's actually a piece of metal in this sound deadening material. And I won't forget the second time. So the other thing I noticed was that this timeout timer was supposed to be 3 minutes. It was 2.5 minutes, probably still okay. But I thought, well, this is a kind of an old circuit. Parts have probably drifted. Things maybe aren't right. So I took a look at the schematic and figured out how the timing occurred. And they just used an op amp with a standard timing circuit. It's a resistor that controls how fast a capacitor charges. The capacitor gets to a certain voltage and the relay switches. So I was able to adjust one of the resistor values, and I got it right up to just about 3 minutes. And that worked out okay. The next step is calibrate the high voltage meter. So this has a panel meter that reads the power supply voltage, and this replacement power supply board has a potentiometer on it, so you can go in there and you can make some adjustments, and you can get it so that you read the correct value of voltage on the meter. But you have to be very careful doing something. You have to make these adjustments basically with the interlock defeated and the cover off. And this is a 3600 volt supply. Okay? So don't do this if you do not have the right equipment. And the right equipment is a high voltage probe and one hand behind your back while you're making the measurements. And at that, you don't adjust the power supply. You make the measurement, you turn everything off. You make sure the capacitors are discharged. You adjust the potentiometer, you turn it on, you let it come back up, you measure the voltage. Now that might sound kind of tedious, but it only took about 3 tries to get it to where the multimeter and the panel meter matched up pretty good. And with that, it was ready to go. The amplifier is good. It's back on the shelf, or back on the shelf in the shack. And so now start testing it, and 65 watts in, 1500 watts out, and the plate current and the grid current match up pretty good with what the manual says. This is a heavy amplifier. Okay, this is 77 pounds. I'm not as young as I used to be, and I'm not as strong as I used to be. I'm very careful when I lift these old radios. And you can see in this one, this is actually up on a shelf at my operating position. So to move this, I have to go up to it. I have to lean forward a little bit, pull it back. It's pretty awkward. And it's not just the weight, but it's a big, ungainly kind of box. It's about 14 inches deep. So it's just awkward to maneuver. And once it's on the table, it's really hard to maneuver too. So just lifting it is only one part. So what I did is I took a lazy Susan, like you might have in your kitchen cupboards or something, mounted it on a piece of plywood and put the amplifier on top of it. I've used this for many years. And this works both at the operating position and on the workbench. And it helps to be able to just kind of be able to move it into the right position without having to fight with the amplifier. It works pretty well. So why go through all this trouble for this amplifier, and why be so careful? There's a lot of projects I do just because I like to do them. Like I work on old radios. I like working on them. I don't really need any justification to do it or to spend time on it. I like it. This isn't quite in that category. This is something that's like, yeah, I use it, but this isn't the part of radio that I really like. So why did I do this? And I did it because I wanted to make sure, number one, I didn't wreck it when I turned it on the next time. And I wanted it to work well when I started using it again. And a couple factors to consider. If you buy one of these new, they cost between $6,000 and $7,000, which I think is ridiculous, remarkable. I did not spend that much when I bought it. I bought it used many years ago. It was a lot cheaper. But if I had to replace it, it's a lot of money. The tube in this thing, an iMac 8877, is $2,000.
That's crazy.
Yeah, that's crazy.
You can find them for less, but I don't know where to dig.
I got a used one for $300.
I bought several used ones.
Who knows if it's any good? But, and the transformer, that Peter Gall transformer, if you have to replace that, that's $400 plus shipping. So that's probably like $500 just for the transformer. And just replacing those original capacitors would have run about $90 for the parts. MFJ still sells them. They're those old computer power supply type with the screws on top, so they're not real common anymore. It was $90 plus shipping for those, so you're probably looking at $100 just for capacitors. So I thought, well, why not upgrade that power supply, make a few changes, make sure everything works okay. So that the cost for those changes that I did was $236. The circuit board was about $40. The parts, the electrolytic capacitors and stuff was about another $160. So altogether, certainly compared to the cost of the amplifier, replacing the amplifier, it seemed pretty reasonable. And I was real pleased that when I got it all put together, except for the one bang that occurred, everything worked out pretty well, and the amplifier is now working just fine.
How about how the noise?
What's that?
What did the noise do after you did
Huh?
all the?
Did the fan?
Yes, the quieting down on the fan actually worked very well. You of course can still hear it. It's not like the noise is going to go away. How do you describe the noise? I don't have any way to measure how loud the fan is. It's quieter than it was. It used to be. So if you're familiar with a Collins KWS-1, you can compare it to that. I've got a KWS-1 in the shed. KWS-1, it's got a blower system in it. This used to be a lot louder than my KWS-1. Now it's quiet. So it's used to be, I think of it like a vacuum cleaner, even though it wasn't that loud. And now it's more like a window fan. Okay, so I would say it's significantly quieter. Would I have to have headphones on? I don't think so. I might choose to still put them on, but it did work. It did work, which I was real happy with because it was a lot of work to get it to that point. Okay. Any other questions?
Pat, can you hear me? I got a question about those bleeder.
He's got a question about the.
Yes, Michael, can you unmute yourself? Michael.
Question about the bleeder resistors. I noticed they're mounted quite high above the board. And I'm guessing that it's because they generate a lot of heat and you want to keep it away from the board. If that's correct, then isn't that a problem with those things getting too hot and burning up themselves? Or why are they up so high?
Yeah, that's a good observation, Michael. They're mounted up above the board to allow some air circulation. The bleeder resistors do dissipate power. The ones that are in here were, I think these are 5-watt resistors. If I remember right, 3-watt, 3-watt or 5-watt resistors. They're mounted up. There's 2 bleeder resistors per capacitor. So the heat is away from the board and it's up in part of the airstream, the cooling airstream for the tube. Actually, it's right where the air is pulled into the amplifier is kind of where the power supply is. So that as the cooling fan is working, it pulls air in across the power supply and then blows it up through the tube. So in a way, it kind of preheats the air for the tube a little bit. That's just the way it's set up. But the way the circuit board is designed is the capacitors are on the bottom, the resistors are on the top. They're separated by quite a bit. And the power dissipation in the resistors, the wattage is selected to keep the temperature correct. So it all works out okay. Any more questions?
I have one.
Yeah, go ahead, Gary.
Some of the heat is removed from the amplifier by conduction from the metal. Do you think that the sounding material you put in there causes any additional heat buildup inside the amplifier case?
I don't think so, because it's not really in the area around the tube too much. The one piece that you can see that's by the tube itself was a piece of phenolic, like a piece of circuit board that had the copper removed. So I don't know that that was doing any heat conducting anyways. And the rest of the metal in the area around the tube is not touched. And the fan airflow isn't impeded. So it still blows up through the base of the tube and out through the vent at the top.
Pat,
No way
Fred,
to
Pat, Fred, I've got a question. And
Yes,
I don't think you addressed it. You put in the two-speed fan switch. How do you know when it's getting too hot? Does it have some temperature readout indication?
That's a very good question, Fred. No, there is no way to tell when it's getting too hot. It would be
Other
something.
than bringing a thermometer down there and setting it over
Yeah,
the top.
you
and
could
watching.
probably stick a thermocouple in there, but I guess the rule that I would follow for that is if I was going to use a continuous mode, like if I was going to do, try to use it for AM or RTQI or something, I would switch the fan up to the high speed.
Did all of those amplifiers have the Peter Dahl transformer in them, or was that an optional thing? And if so, how do you know which amplifiers have which transformers?
I mean, all of the AL1500s.
Yes, that I guess that was my question. I thought I remember reading someplace that they didn't all have the same power supplies, but I didn't know if that was something you can tell from the outside of the case. I'm thinking if you buy one, at a swap fest or something, do you have to look inside?
And that's, I can't answer that. I don't know for the, like the 30-some year history of this amplifier. I don't know if they always use the same one or not. As far as I can tell, it was never an option to have a different transformer. And the ones that were produced at the period of time that mine were bought all seem to be the Peter Dahl. That's what all I can tell you about that. I suppose you're right, Fred. If you were going to buy one at Swap Fest or something, you could take a look inside and see, and that would probably be a prudent thing to do anyways when you're buying a piece of used equipment, is look inside, especially if it's an expensive piece of used equipment. Any other questions? Thank you very much. Okay. Thank you, everybody. And even though we were talking about the AL1500 tonight, this is stuff you can pretty much use on any kind of a big tube amplifier. This isn't really specific to that one.